Okay, so some more about the anatomy of the eye. The optical components are anything that allow the light rays to enter the eyeball and then eventually focus images on the retina. And we begin with the cornea, very, very important structure. It's the most commonly transplanted structure in humans, and it is the transparent cover that we've already discussed. That's part of the tunica fibrosa. Then behind the cornea lies the aqueous humor that bathes the cornea, that bathes the lens, that bathes the iris as well. And so this is that fluid. It's produced and reabsorbed at the same rate, hopefully. If not, then you may have problems with intraocular pressure. So we see the cornea presented here, the lens behind it. The cornea is going to do an enormous amount of light bending and so forth, and the lens is going to help to focus the image somewhat. And then the ciliary body that helps attach the lens, along with the suspensory ligaments, the posterior compartment, the anterior compartment, that is full of aqueous humor. The posterior compartment, remember, is full of vitreous humor. So we can see the aqueous humor production and its flow through the anterior chamber of the eyeball here, through those blue arrows. So again, as much produced as is reabsorbed. The lenses are really neat, especially if you dissect an eyeball. I wish y'all could do it and see them. They're held in place by these suspensory ligaments that can change the shape of the lens. They can flatten it by relaxing, amazingly, or they can allow it to fatten up, the lens that is, to fatten up by contracting. Okay, so that's what I just said. I didn't lie to you. All right, so the vitreous body makes the largest portion of the eye and fills the posterior chamber, and it's just a jelly. It's really, again, really cool to deal with. So we see the sclera that contains the vitreous humor, the cornea, the suspensory ligaments, just more anatomy for you to get familiar with the eyeball. These are actual slices from an eyeball showing you the structure of the eyeball. Now, what are the neural components? What are the ones that are going to take now this energy that is striking the back of our eyeball called the retina, that layer? How are we going to send that to the brain? And so the retina, this centralized region that is high in photoreceptors called the fovea, and then the optic nerve that transmits the information to the occipital lobe. So the retina is part of the diencephalon, not particularly important. It keeps its shape by the presence of the vitreous humor. You can damage or detach the retina. It's a very difficult thing to deal with sometimes. Older people can experience this also with more problems. And so you can look at the retina, right? What's the doc doing? The eye doc, when he's looking in your eye with that ophthalmoscope. So he's looking at the cells of your eye and so forth, making sure there's nothing unusual. There's a patch of cells on the retina called the macula lutea, and in that patch of cells is the fovea centralis, and we'll just call it the fovea. And the fovea is the most important part of the retina. It's where your central vision will be established. There are blood vessels in the retina. You might think they would interfere with detection of light, but they don't, for the most part. Okay, so here's our optic nerve, right? The optic disc, our blind spot, and then the retina. These are the neural components of the eye. You can see the pathway of the optic nerve that we've looked at previously in chapter 14 for the brain. So here is the relationship between the blind spot or the optic disc. You can see this is where all the blood vessels are coming and going. The arteries are delivering blood. The veins are taking the blood away. We're going to have all the nerve endings from the retina going to enter to form the optic nerve here. So there's no place for photoreceptors in this spot, and that's why it's called the blind spot or the optic disc, right? And you can see this patch here. This is the fovea centralis, the area of central vision in the eye. Okay. Alrighty, so we can see them laid out here in all their glory and beauty. This is one way to test your optic disc. I don't know if it'll work off the computer, haven't tried, but you can check out your blind spot. So there are no receptors, as we already talked about that. Close eye, stare at the X, and then see if the red dot disappears. At the position it disappears, that's the distance that you cannot see due to the presence of the blind spot. Okay, and here's a shot of it, beautiful shot of the nerve fibers going in and out. You can see the retinal material, the retinal photoreceptors back here. Okay, so what about some conditions that can affect the eye? Cataracts are a clouding of the lens. And so as you age, the lens fibers can begin to darken. You can get these fluid-filled bubbles and little gaps that appear in between the fibers of the lens. This can be caused by many things along with aging. And you can replace the natural one with a plastic one. Okay. So what happens in glaucoma? This is where you have improper drainage of your aqueous humor. I briefly mentioned this earlier. When you get less reabsorption than production, you're going to get a buildup of pressure, and that's bad, right? That's always going to be bad for anywhere if you have too high a pressure. This can then cause a pressure to form on the retinal cells, causing them to die from lack of oxygen. You'll see flashes of light and halos around things for later symptoms, and once it's gone, the retina is destroyed. There is no artificial retina